Let's continue introducing some more NumPy functions. And, well, let's start from a simple example. All right, let's start from importing NumPy as NP, and then create a new array as a range from 1 to 6. NP a range 1 to 6. So we've looked enough at generating new arrays and slicing them, but let's perform some simple manipulations on them and get some calculate some properties of this array. For example, we can calculate the sum of this array. So obviously the sum from 1 to 5. Well, and there could be two options to do that. There could be a method of the array itself or a method of the NumPy module. So we can do NumPy sum a, and it will return us the same exact thing. We can calculate a product. A prod would be and the same NumPy product a. Right? We can do a lot of statistical analysis on it, but we're not going to talk in detail about statistics right now, but I can show you just, well, the simple arithmetic mean we can do. And again, I think if you do NumPy mean of a, it will give you the same thing. And by the way, notice that here, while there was an array of integers, when we started calculating the mean, when we started to use statistics, it converted the integers to floats. Similarly, we can do the variance, so NumPy variance of a. And as I said, well, that's enough for now. We can get the minimum and maximum values in the array, so a min or NumPy min of a, or in same with maximum, a max or NumPy max a. Furthermore, we can get the indices of the minimum and maximum values in the array. So it could be a arg min. Oops. Well, that's just a typo. So the 0th element is the minimum, and we can do NumPy. We can do arg max and get the index of the last element. And again, I think if we do NumPy arg max, okay, we'll do the same thing. Then, well, that's for one-dimensional array. Let's see what if our array is a little bit more complicated. Let us create an array range NumPy range from 1 to 7. All right, so this thing can be easily reshaped. Let us reshape it to the matrix 2 by 3. Let's see, 2 by 3. So if we print D, this is what we get. And we can certainly calculate minimum, so say D minimum, and well, obviously it will be still the same element. However, in addition to that, we can calculate the minimum or the maximum along a certain axis, because now it is a two-dimensional array, so we can do it along this axis or that axis. So let's calculate the D minimum of axis equals 0. So it will calculate, it will take each of these columns. So let me open it here. So each of these columns and calculate the minimum in each of these columns. And what it returns an array of 3 elements corresponding to the minimum in each of those columns. Or we can calculate the minimum axis equals 1, and it will do the same for the rows. So if we look here, this will be the minimum in the first row, and this will be the minimum in the second row. Another quite useful method would be the NumPy where. So let me give you an example. So let us introduce a new array, NumPy range. Let's say a range from 5 to 10, right? So to 11. So it will be 5, 6, 7, etc. So is now this array, and let's say I want to find the indices of the elements which are, let's say, greater than 8, right? It will be the last 2 elements, obviously. So for that, we can use a NumPy where a greater than 8. So that will return us a tuple of NumPy arrays. Well, there will be only this array 4 and 5. Note that these are not the elements themselves, but just the indices. So in fact, what I can do, I can say that let's say I introduce these indices. All right, it's an index of it's a tuple of arrays, but then I can use those to actually slice my my array. So if I do a indices, then it will return me the slice of my initial array where the elements are greater than 8. So my last 2 elements of this array. So that is quite useful when we have arrays of data and we want to see if certain condition is applied and take just a part of these data. Well, NumPy where can actually be a little bit more advanced with that. It doesn't necessarily have to return the indices, it can return something else. So for example, let's say we want, let's create a new array. We want to have, for all the elements where, which are greater than 8, we will be returning the elements themselves. So I can say for a NumPy where a is greater than 8, we'll return the a itself. And there is a, well, the else condition, so basically when this is not fulfilled, we can return something else, and let's return a squared. So let's see what it's going to give me. We generated this array C. So as you can see, so for those last 2 elements which were greater than 8, we return A. And then for the first 4 elements which were less than 8, we returned the squares of these elements. So again, pretty complicated construction, but sometimes it is quite useful.